number 6, it asks us, find all the solutions for each triangle. If no solutions exist, write none. Well, number 5 was none. Okay? But it says round to the nearest 10. You got to figure out, first of all, do we have a certain number of solutions for this triangle? So right now, which case are we dealing with? We are definitely dealing with case number 1. We have an acute angle. So right now, I'm going to list A, and I'm going to compare it to B. We have 125 in comparison to 150. That's definitely less. Then I have to go to the next step, which means I got to check, is A, what's the relationship to A in comparison to B times the sine of A? So we're going to do a little test here. My B value is A, 150. The sine of 25 degrees is going to give me an approximate value. What is it equal to? 63.4. If you type it in the graphing calculator. So in case you're wondering how to type it in, just type it in. Literally 150 sine 25. Press enter. That's how they got the 63.4. Okay. Oh, look at this. A is what? Bigger than B times the sine of A. So A is less than B, but A is greater than B times the sine of A. In which rule does that let us know? We have 2 solutions. Now that we know we have 2 solutions, we need to solve for all the angles and all the sides. So right now, what I want you to do, in your journal, right now, I want you to list angle A, angle B, angle C. Angle A we know specifically is what? 25 degrees. And I want you to write lowercase a, lowercase b, lowercase c. We know lowercase a is 125. We know lowercase b is 150. So now what do we need to figure out? We need to figure out what angle B is, what angle C is, and what side C is. We're going to use the law of sines to do this. But before I do it, I want to show you the picture of the triangles that we're going to be working with. Okay? So I want you to do your best to draw these triangles with me. First thing I'm going to do is I'm going to draw a 25-degree angle. There's my flat, my nice base right here. That's going to be my side C. Okay? I'm going to get my protractor out. I'm going to draw as best I can a 25-degree angle. It's pretty easy right here. There's 25 degrees right there. So right now, there's 25 degrees. About like that. Now, this side right here is side B. And side B was what? 150, correct? Here's angle A. That's a small little sliver right there. That's 25 degrees. Right now, side A is slightly what? Slightly less than that 150, so I'm going to estimate right there. I'm going to estimate that this side A is 125. Here's capital B. We need to find capital B. We also need to find capital C. Now, this is one of your triangles. All right. So right now, this is one solution. This is what one solution will approximately look like. But we also have what? We have another triangle that could fit in here. So the other triangle we're going to build, everybody, I'm going to do a dotted line so you can see what I'm doing. Watch what happens if I swivel this side way over here. You see that? That could be my, I'm leaving it a dotted because that could be my other possible triangle. So here's my other possible triangle that we're going to need to solve for. Do my best to kind of make this match. All right. There's angle A. This is angle C. This is angle B. What stays the same? The B is still 150. The lowercase a is still 125. But do you see there's two totally distinctly different triangles? That's why this is the other solution with it. This is one solution. This is one solution. Now, This angle B is obtuse. This angle B is what? Acute. This angle C up here is obtuse. And this angle C right here is acute. So we need to know when we solve for something, we're going to use the law of sines to solve for it, that, if I get an angle B that's greater than a certain amount, we've got to put it in one of two triangles. So here's what we're going to do. You're going to use the law of sines. So right now, put A over the sine of A equals B over the sine of B. Right now, in your journal, we are going to solve for angle B. That's what we're solving for. Okay? We're going to solve for angle B. Okay? All right, now let's plug things in. What is lowercase a equal to? So write 125 over the sine of capital A, which is 25, equals B, which is what? 150 over the sine of capital B. So here's your proportion. I'm going to move to the right so we have a little bit of room to work. Let's cross multiply and solve for angle B. We're going to cross multiply. And here are our cross products. I'm going to write 125 times the sine of capital B equals 150 times the sine of 25. To solve for B, I have to divide both sides by 125. These will cancel out, and this is what the sine of B, which represents the angle, is equal to. So I'm going to write the sine of capital B is equal to 150 times the sine of 25 all over 125. Now everybody, this right here will equal some decimal. Whenever you're solving for an angle, what do you always have to do? You have to use the inverse button. So whatever you get for that decimal, you're going to do the inverse of sine. And I'll show you how to do that in the calculator. Right now, I'm going to type in. Let's see what we have. We have what? 150 sine 25? There's 150 sine 25, right? 150 sine 25. And what are we going to divide that by? We divide that by what? 125. Do you guys see that decimal? So we're going to take the inverse of sine, and what are we going to find the inverse of sine to? Whatever that decimal is. And that's your angle. What is the measure of our angle? About 30.5 degrees. So right now, I want you to understand that capital B is approximately equal to 30.5 degrees. When it said round to the nearest 10, I just rounded it to the nearest 10. So there's our angle B. Now let's look over here. This one's acute, this one's obtuse. I would say the 30.5 is definitely going to go in that slot right there. How do I find the obtuse? It's really easy. Whatever you get, do 180 minus that acute angle, and that gives you your other possibility for angle B, which is 149.5. So right here, up here where it says solutions, what is one of the possible measures for angle B? 30.5 degrees. What's the other possible? 149.5. So angle B can have two different answers. Why two different answers? Because how many different triangles can we make? Two. One has an acute, one has an obtuse. Now how do we find C? Pretty easy, right? Just do 180 minus all of these. So this one right here is going to be 180 degrees minus 25 degrees minus 30.5 degrees. What's this angle going to equal? 180 minus 25 minus 149.5. So what does this angle C measure to? 124.5. Add all those up, and what do you get? You get 180 degrees. All right? What does this one add up to? What does this equal? I think that only equals, what, 5.5 degrees, which makes sense, because that's a really, 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 really tiny little sliver. Okay, that's why it's 5.5. So our two final answers for angle C are what? 124.5 degrees and 5.5 degrees. 25 degrees, 30.5 degrees, 124.5 degrees, they add up to 180, and these three also add up to 180. So now guess what we only have to find? We only have to find C. How many answers do you think we're going to have for C? 2. We've got a really big one, right? It's a long one. And we have a really, really, really tiny one. Okay, so we're going to set up the proportions to solve for that. Here's what you're going to do. We're going to, right now in your journal, you're going to write solve for lowercase c. We're going to set up 2 proportions. The first proportion is this. A over the sine of A equals C over the sine of C. The other one is going to be this. A over the sine of A equals C over the sine of C. It's a little redundant. What was our side A equal to? 125, right? Start out the exact same way. What's our angle that we're dealing with? 25, right? What's the only difference right now? We don't know the value of lowercase c, but what's the first one we're going to use? Let's use the what? 100 and... What was one of our angles for c? One of our angles was what? 124.5? So you're going to use what? You're going to use 124.5. What's the other angle you're going to use? 5.5. This is where you're going to now cross multiply. You're going to cross multiply this. You're going to cross multiply this. Here are your cross products. C times the sine of 25 equals 125 times the sine of 124.5. Here's your cross products for the other one. C times the sine of 25 equals 125 times the sine of 5.5 degrees. The last step is just to divide both sides by the sine of 25. So in the calculator, if you do this, you will get the correct answer. This right here is one distance. This right here is the other distance. You have to use the get rounding calculator, type it in, and those will give you the 2 approximate values for C.